Hello everyone, welcome to our course on electrical drives. In our day-to-day life, almost everything that moves electrically is driven by an electrical drive. Whether it is an electrical fan in our home, an elevator in a shopping mall, a conveyor belt in a factory, or even electric vehicle, all of them use electrical drives. So, in this chapter, we are going to understand what an electrical drive is, why it is needed, what its major components are, and the different types of power converters used in the electrical drives. So, let us get started. What is an electrical drive? An electrical drive is, simply speaking, a system that uses an electric motor to control the motion of a mechanical load. Now you may ask, what do we do actually? What do you mean actually by controlling the motion? It simply means we should be able to control three things. First, the speed of the motor. Next, the torque produced by the motor. And the third, the direction of rotation. If we can control these three quantities according to our requirement, then we have an electrical drive. Think about an elevator. When you press the fifth floor, the elevator should start smoothly, travel at the required speed, and stop exactly at the fifth floor. All this is possible because of an electrical drive. So, electrical drive is a system that uses an electric motor to control the motion of a mechanical load by controlling its speed, torque, and direction. When we come to application, electrical drives are almost used everywhere. They are used in electric trains, rolling mills, paper industries, textile industries, pumps, fans, compressors, robots, whatnot. In short, whenever controlled motion is required, an electrical drive is almost always present. Now let us look into the block diagram of an electrical drive. Now let us understand the overall structure of an electrical drive. Don't worry, this block diagram may look complicated initially, but it is very simple. We begin with the power source. This supplies electrical power to the entire system. Next comes the power modulator. This is one of the important component of the drive. Instead of supplying power directly to the motor, we first process the power. The power modulator controls the voltage, current, and frequency supplied to the motor according to their requirement. Next comes the electric motor. After that, the electrical power reaches the electric motor. The motor converts electrical energy into mechanical energy and the mechanical load. The motor then drives the mechanical load. The load can be a pump, a conveyor, an elevator, or any machine requiring motion. Now let us come to the sensing unit. But how do we know whether the motor is rotating at the required speed? For that, we use the sensing unit. It continuously measures quantities like speed, current, and sometimes even position. All this information is sent to the control unit. The control unit compares the actual speed with the desired speed. If any error is found, it immediately sends a corrective action to the power modulator. The continuous correction is called closed loop and is the reason modern drives are highly accurate. Now let us come for the third section of this presentation, functions of power modulator. Its first job is to control amount of power supplied to the motor. Secondly, during motor starting, the starting current can be very high. The power modulator limits this current and protects the motor. Thirdly, it converts electrical power into a form required by the motor. For example, it may convert AC into DC, DC into AC, or change the voltage level. Finally, it allows the drive to operate in different modes such as motoring and braking. Advantages of electrical drives. Why are electrical drives preferred over mechanical drives? There are many reasons. They provide flexible speed control, they have high efficiency, they are very reliable, They require very less maintenance. They produce less noise. Starting is fast and smooth. Many electrical drives can even recover energy during braking. This process is called regenerative braking. Modern electrical drives are also environmental friendly and can be easily automated. Parts of an electrical drive. Once again, let us quickly identify the major parts. They are power source, power modulator, electric motor, control unit, and mechanical load. These five blocks together form a complete electrical drive. Next comes electric motors used in electric drives. Different application requires different motors. For DC drives, we use DC motors such as shunt, series, compound, and permanent magnet DC motors. For industrial applications, induction motors are the most popular. Depending on the rotor construction, they are classified as squirrel cage and slip ring induction motors. We also have synchronous motors, brushless DC motors, stepper motors, and switcher reluctance motors. Each motor has its own advantages and applications, which will be studied in the later chapters. And next comes the power modulator. Power modulator itself can be broadly classified into three categories. They are converters, variable impedance controllers, and switching circuits. Among these, converters are the foremost used in modern electric drives. Power converters. There are five major types of power converters: AC to DC, also called as rectifiers; AC to AC converters; DC to DC converters, also called as choppers; DC to AC converters, known as inverters; and cycloconverters. Each perform a different type of power conversion depending on the application. Now let us look into AC to DC converter. Now let us understand different methods of obtaining a DC supply from an AC source. The simplest one method is the diode rectifier. It converts AC into DC, but the output voltage is fixed because diodes cannot be controlled. Next is the fully controlled thyristor rectifier. By changing the firing angle of the thyristors, we can obtain a variable DC voltage. The half controlled thyristor rectifier works in a similar way, but it uses both diodes and thyristors. Another method is to use a transformer with taps before the rectifier. Changing the taps changes the AC voltage, which in turn changes the DC output voltage. A diode rectifier is followed by a chopper is another popular approach. Hence, the rectifier produces a fixed DC voltage and chopper varies it electronically. Modern high performance drives uses the self-commutated devices like IGBTs and MOSFET. They provide better efficiency and fast control. Before power electronics became popular, motor generator states, magnetic amplifiers, and amplidynes were used. Although these methods were rarely used today, they are important for a historical point of view. Next, let us look at AC voltage controllers. The first method is to use an auto transformer. Since the turns ratio is fixed, output voltage is also fixed. A transformer with taps allows us to obtain different voltage levels by selecting different taps. The most widely used today is the thyristor AC voltage controller. By controlling the firing angle of the thyristors, we can continuously vary the RMS output voltage without changing the frequency. Magnetic amplifiers were also used earlier for AC voltage control, but nowadays semiconductor based controllers are much more common because they are smaller, faster, and more efficient. Next, we look into the section of DC choppers, inverters, and cycloconverters. DC chopper is capable of delivering a variable DC voltage from a fixed DC supply. The advantages of it are high efficiency, fast control, and compact. The inverter converts fixed DC into a variable frequency AC. there are two types generally: stepped wave inverter and PWM inverter. Cyclic converter, it converts fixed AC into a variable frequency AC. The features are variable voltage can be obtained and variable frequency can also be obtained. They are thyristor controlled and used for high power drives. So let us quickly summarize this lecture. An electric drive is a combination of power source, a power modulator, motor, control unit, sensing unit and mechanical load. The power modulator is the heart of the drive because it controls the electric power supplied to the motor. Different converters such as rectifiers, choppers, inverters and cyclic converters are used depending on the application. Finally, thanks to the feedback and control systems, modern electric drives provide precious, efficient and reliable operation. In the next lecture, let us discuss on the modes of operation of a electric motor. Thanks for your listening. Thank you.